For the following exercises, determine whether there's a minimum or a maximum value for each quadratic function, and then find that value and the axis of symmetry. Okay, so we have two quadratics here. I know we have a quadratic because the highest power for each function here is a squared. So that's a quadratic function. If the highest power is a 2 on your variable, so in both cases there's a 2 here, and that's the highest power, you have a quadratic. And now we know that quadratics look very, very simple. And what I'm going to do is I'm going to draw in this case, but at some point I'm going to have to erase because we have a lot of math to do. So if you guys want to just jot this down as well, you can go for it. But just know that quadratics are very simple, right? Here's my lovely y, x coordinate plane that we love, right? And quadratics, they're very simple. I've said that like 5 times, but they are. They either smile, you see how it's literally like a smile, whee, right? So quadratics, they either smile at you or they frown at you. And let me draw that, weep. They go down like this. That's it. We just have to figure out, which one is which. Now, if we notice here at the smiling, there is a low point, right? Right here. There's a point in which the quadratic will turn. It's going down, 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 and then all of a sudden it goes up, 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 right? This point, whenever we basically turn over, this point is called the vertex. So we have a vertex at the way, 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 way bottom for this quadratic example in general. And it looks like we have a high point for our frowny face, right? And this would be our vertex for this example. Now, what would we classify them? Well, since on the smile quadratic graph, right, it's a low point, this you would actually have a minimum value. And sometimes they call it the minima. But for here they're saying, minimum value or maximum value, but just know that minima and maxima, they're the same exact thing. On the frowny graph of our quadratic, I have a high point, right? This vertex is the highest point on the y-axis that I can go. So I have a maximum value, and this is called a maxima. So you could hear your teacher say both of them. But now how do I know if a graph is going to be smiling at me or frowning? Well, it all comes back to the a value in the quadratic function. If your a value is a positive, I don't care what positive it is, a +1, a +2, a 1/2, that's positive, right? A 3/4, a 4. You are smiling, and think about it, right? If you're positive, you're going to be smiling as a general term. In your frowny graph, right? What would your a value be? Oh, your a value would be negative. So -1/2 or -4 or -3. It just has to be a negative. So negative goes with frown. Positive goes with smile. But then just know that for a value that's negative, you always have a max value. It will always look like this. The vertex will be at the highest point. If you have a min value, your a would be positive. It would be all the way at the bottom. Now, remember, your a value is always the value that is going to be in the front of your variable that is squared. So in this case, it's x squared, and in this case, it's t squared, right? So in this example, we have a equals 4, and that's a positive. So I know that I actually drew this type of graph to be a good one. It's a smile, right? So it's going to have a minimum value. So we already answered that part. Minimum value. And we could automatically answer this part. For here, our a is a -4. My A was negative. It's a frowny. So my vertex has to be a maximum value. Okay. Now, do I know that this function is giving me this exact graph? I have no idea. I don't know if maybe the smile is down here. I don't know if it's more up above, right? I don't know if maybe it's shifted over. All I know is that it's just a smile in general. And the same thing for this one. I don't know if this is the exact graph. I don't know if maybe it, frowns down here or maybe it frowns over here. So now we just have to figure that out. That's when we have to find that value and the axis of symmetry. But the answer always comes from the vertex. Keep in mind that your vertex is just a point, right? So and I will write it over here, vertex. Your vertex is just a point, right? It's an x comma y. However, when we talk about a vertex, we talk about it in terms of h's and k's, right? And you can remember this by, h comes before k in the alphabet. So the h value is the x value, and the k value is the y value. So for this vertex, this point, you have a h and a k, right? And for the other one, you have an h and a k as well for your vertex. Now, the axis of symmetry always comes from the h value. It's just the x value. So whatever your h value is for the vertex, that's the answer for axis of symmetry. And you can see that by splitting this in half. That is what an axis of symmetry is. It's just showing you that this is the turning point from going down to going up. And then over here, this would be the axis of symmetry. I drew it right on the y-axis, so it's kind of hard. But the same exact idea. Your value for your minimum is your k value. So just know that. The x value or the h value of your vertex will tell you the axis of symmetry. The y value of your k value will tell you the value of the minima, right? So now I'm going to erase because now we have to find out what the h and the k is, and then we can solve this problem. So pause the video if you want. You could write down these lovely graphs, but now we just got to do the math. So I'm just going to erase. Whee! Okay, bye-bye. It was nice. It was nice knowing you. Okay. So we've done tons of problems like this in which we know how to get an h and a k value, right? So the first thing is, I'll say over here, the first thing is we have to find h, right? And I'll just put that down here again. The vertex was really just an h comma k value. Okay. We know that h, from previous examples, is just a formula of negative b over 2a. Here is my formula, right? My formula is f of x equals 4x squared plus x minus 1. Let's run through what a, b, and c is for this formula. F of x equals 4x squared plus x minus 1. Remember, your a value is in front of the x squared, your b value is the number that's in front of the x, and your c value is the one all by its lonesome. Keep in mind, you do have to take into consideration the signs. That's going to tell you if that number is positive or negative. So we said before that our a was 4. I don't see a number in front of the x, right? There's no number here. So there's a secret 1 here. And then for the c, you have to include that negative, so it's a negative 1. So there's your a, b, and c's. Let's just quickly do this math, because then we can find the axis of symmetry. My h would be equal to negative 1. The negative is in the formula, so I have to keep that. Negative 1 divided by 2 times 4. So if I simplify this, it would be negative 1 over 2 times 4 is 8. And that is your h value. Now, when you're saying it in terms of axis of symmetry, remember the graph that we know and love is always y and x. it is never k and h. So you just have to say this in terms of an x value. Remember, the h is the x value. So the axis of symmetry, you would just say x equals negative 1 over 8. So my axis of symmetry would be x equals negative 1/8. And that's the answer to the first part. Okay. Now, if I just plot this quickly as to what this actually means, remember the axis of symmetry is the line that's going down the graph where the graph turns. So negative 1/8 on the x-axis would be somewhere over here, very close to the origin. So I know at this point that my graph is going to turn somewhere on this line, right? But I don't know if it's going to turn here. I don't know if it's going to turn here, right? But each one of them turns, or I tried to at least draw it, at that point. Now let's just find that k value. That's the second thing. Second thing is find k. Oh, find k. And we know from previous examples, k just equals f of h. All you're going to do is you're going to plug in h for your variable into the problem. So, for all of my f of x's equals 4x squared plus x minus 1, I'm now just going to substitute in my x value, which was the negative 1/8, or the h value, which is the same thing. So instead of saying x, I'm just going to say negative 1/8, and that means that all of the x values have to get plugged in as well. So I know that this has to be a negative 1 over 8. And I know that this has to be a negative 1 over 8. And plus a negative just means that it's negative. So we turn into this formula. Now let's just solve. Exponents first. So I'll do it over here. Negative 1/8 times negative 1 over 8, right? When you multiply the top numbers together, you multiply the bottom numbers, the denominator, and that's the end of that. So this would be a positive 1 over 64. So this would equal 4 times 1 over 64 minus 1 over 8 minus 1. Now let's see. Can we simplify 4 into 64? Is there an actual number that goes into 64 and 4? Yes, there is. It's 16. So I can cancel out the 4. And 4 times 16 is 64. So now this just equals 1 over 16. So let's just get rid of this. And now we have a nice thing that we just have to simplify. We just got to clean it up. So 1 over 16 minus 1/8 minus 1. If you want to put this all into the calculator, you can. I'm just going to do it with fractions because I love fractions and I'm only the one that likes fractions. Go me! Anyway, so remember, when you're when you're adding or subtracting fractions, you want to get the denominators the same. The highest denominator here is 16. So what can I multiply by 8 to get to 16? 2, right? But whatever I do on the top, I got to do, whatever I do on the bottom, I got to do on the top, right? So the top would be 2 over 16 instead of 1 over 8. So I'm just going to get rid of this, and I'm going to say 2 over 16. And now I just need to minus 1. Now, anytime that you need to put a one number into a fraction, you just say the same number that you want for the denominator as the numerator. So I want it to be a 16, so I just put a 16 on the top. 16 divided by 16 is 1. So now I have a good common denominator. I can do my subtraction on the top, and remember, you keep the denominator when you are adding or subtracting. So I'm just going to put the answer over here. 1 minus 2 is a negative 1 minus 16, and this is all over 16. Negative 1 minus 16 is a negative 17. And that would be over 16. And that would be your k value. That is the value of your minimum, because we know that we're smiling here. So there you go. This is the answer for the first one. We have the value of the minimum at negative 17 over 16, and we have the axis of symmetry at negative 8. So if you plot these 2 points, keep in mind that your k is the y value. You will see exactly where that graph will turn. Let's move on to the second one, and let's find that value and that axis of symmetry. Remember that this one was a maximum because my a value is a negative. So it's going to be frowning, but we just don't know where. So let's find h and k. The first thing we're going to do is we're going to find that h, right? And h always equals negative b over 2a. So let's just list out what the a, b, and c are for here. Good practice. We said before that a was a negative 4. I have a positive 6 here and a negative 1. So my b value would be a 6 and my c is a negative 1. Plug these values in for here. So this equals negative b, which was 6, divided by 2 times a negative 4. That was your a value and the b value. So if we just clean this up, we got negative 6 divided by negative 8. Negative divided by negative is a positive, so that goes bye-bye, right? And let's see, is there any number common between 6 and 8? Yeah, I could both times 2 to get to 6. 2 times what will get 6? 3. 2 times what will get me 8? 4. That is the simplified number. And that technically equals h, right? So we'll say equals h. Oop, equals 4. Christina. Ah. There we go. And remember, when they're asking for an axis of symmetry, technically you can't say h because the graph is not meant for h's and k's. It's made for x's and y's. So your axis of symmetry is x equal 3/4 because your vertex, the h, is the x value. Okay, so we did the first part. Now, we just gotta find out the k value. And remember, the k value is where you just plug in all of your h values into the formula. So the formula was h of t equals negative 4t squared plus 6t minus 1. But my h value was a 3/4. So for all of the t values, you're going to plug in a 3/4 into that. So this would be, and let's see if I could color code this one, negative 4 times 3/4, and that is all squared, plus 6 times 3/4, and then minus 1. Exponents first, I got to do 3/4 times 3/4. I'll do it down, well, actually, I'll do it up here. 3/4 times 3/4. We're multiplying fractions. We multiply the top, we multiply the bottom, and that's it. 3 times 3 is 9. 4 times 4 is 16. Is there any number, let me just put that a little bit this way. Is there any number that goes in 9 and 16? No. So this would be equal to negative 4 times 9 over 16 plus, let's see if we could clean this up. Now we can do 6 times 3 is 18 over 4. Let's try to simplify it though. I see a 6 in the numerator. I see a 4 in the denominator. Is there any number that can be multiplied to get to those two numbers? Yeah, right? A 2. 2 times 2 will get me 4, and 2 times 3 will get me 6. Now I multiply. 3 times 3 is 9. I just have a 2 over here. So this would be the same thing as 9 over 2. And then I got minus 1. Now let's clean this up. I see that I have a 4 over here and a 16 at the bottom, right? Well, this one can clearly cancel because I know that 4 times 4 is 16. So this cleans up nicely into a negative 9 over 4. So I'm just going to erase that. So I have a negative 9 over 4. The same idea is happening as, what we had before. The highest number is a 4 in my denominator, and I'm adding and subtracting fractions. So I need to get this 2 to be a 4. What number times 2 will get me 4? Oh, times by 2. Well, whatever number I do, I got to multiply it by the top 2. 9 times 2 is 18. 2 times 2 is 4. So instead of saying 9 over 2, you'll say 18 over 4. So I will do that. So this is plus 18 over 4. And now remember, the trick, if you want to just turn a number into a 1 number into the fraction, the same number for the denominator goes for the top. So this would be 4 over 4. And now I have everything nice and neat, so I can just add and multiply the numerators. So let's do it over here. Negative 9 plus 18, that's a 9, minus 4, and this is all over 4. 9 minus 4 is 5. And you can't simplify that, so this would equal your k value. And that's the value now of your maximum. So this is the value. So maybe I'll just say value. Whee! And this is the axis of symmetry. So technically this is your y and this is your x of the vertex in which you will be basically frowning. Your a is negative. So if you wanted to plug that in, you can, just to see what the graph looks like. But other than that, that's all I got for today. I hope this helped. I hope you guys understand what minimums and maximums are and how to find the axis of symmetry for quadratics. Let me know in the comments what you think. And give this video a like. And if you want to subscribe to the channel, that would be awesome too. Thank you so much. It's crazy, what this channel is doing, and it's fun. It really is fun helping you guys out and talking to you guys. All right? Good luck on your tests, and I'll see you guys all in the next lesson. Have a great day. Bye-bye.